Hello and welcome to AI for Developers. I'm Chaitanya talking bot. Today's lesson is titled Generative Adversarial Networks. GANs. Creating realistic images and videos. AI art. Imagine two artists competing. One, the generator, tries to create fake masterpieces. And the other, the discriminator, tries to spot the fakes. They get better and better at their jobs over time, leading to incredibly realistic art. That's essentially how GANs work. A generative adversarial network uses two neural networks in a continuous competition. This neural network is like a talented forger. It starts by making random noise, think scribbles, and then learns to slowly transform it into a realistic image, video, or even song, based on the feedback it gets from the discriminator. It's learning to create believable data. We train it with images and videos so it can generate similar ones. This network acts like a highly skilled art critic. Its job is to distinguish between real images, videos from the training dataset and the fakes generated by the generator. It learns to identify subtle flaws and characteristics that give away the fakes. It provides feedback to the generator. The generator and discriminator play a continuous game. The generator tries to fool the discriminator, while the discriminator tries to catch the generator's lies. This ongoing competition pushes both networks to improve, leading to increasingly realistic output. Think of it like an iterative optimization process. GANs aren't just for creating AI art. They are used in drug discovery, generating molecular structures, video game development, creating realistic environments, and even in medical imaging, enhancing image quality and generating synthetic data for training other models. The possibilities are vast. While implementing GANs requires deep learning libraries, let's conceptually represent it. Generator takes random noise to processes it with layers to outputs a generated image. Discriminator takes an image, real or fake, to processes it with layers to outputs a probability, real or fake. The training aims to minimize the discriminator's accuracy on the generated images, while maximizing its accuracy on real ones. We use backpropagation to adjust the weights and biases within the networks. You can start experimenting with pre-trained GAN models and libraries like TensorFlow or PyTorch. There are many online resources and tutorials to help you begin your journey with GANs. Remember, start small, experiment, and have fun. Thanks for watching. If you found this helpful, make sure to subscribe to our channel and hit the like button.